Hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 29 of the December daily Leetcode challenge. We have around 2 days remaining and then we'll be heading for 25. And currently we are taking questions on DP. The topic is dynamic programming DP. And again today we are having a hard question. So yesterday also, that is the Saturday, we had a hard question on the DP topic. And today also we are having a hard question on the DP topic. So these two weekend questions are hard on the harder side. Let us see what this question is. Yesterday's question, I've uploaded detailed solution. Please go and check that out. That was on a 3-pointer topic. So I've already uploaded the video for that. Please go and check that out. And coming to today's question, it's again a very interesting question. See, these kind of questions is the exact something that you can expect in an interview, because there are multiple ways of doing it, like the bottom up, top down, everything kind of thing you can do. So the way that I have done, I will show you now. But yeah, like I will show you the whole process this time, like what you exactly need to do. So the idea is I will try to show you the evolve, how the solution is going to evolve. The first solution, the second, the third, and fourth. I will show you all these four. And remember, the fourth will be the most optimal solution that is beating around 92% of the test cases, okay, in Python. I will show you that as well. But yeah, I will just want to show the whole evolution that can come in this kind of questions, okay. So this is what I expected in an interview also. You can just follow the same. I'm damn sure you will be able to get a lot of content out of this particular video. So starting the question, it is 1639. Number of ways to form a target string given a dictionary, okay. So if you see the input, we are going to be given a words, that is we are going to be given a number of words, and the given constraint is that all the words are going to be of the same length. For example, if you see this particular word is of the same length as this particular word, and so on, like all the words will be of the same length. Then we'll be given a target, okay. We'll have to form this target using the individual characters in each of the words, okay. We'll see what are those conditions. We'll see that now. So let me zoom in, let us begin. So you are given a list of strings of same length words and a string target. Okay, I have shown you this both. We are given a array of strings called words and a target. Your task is to form target using the given words under the following rules. Target should be from left to right. To form the ith character, zeroth index, that is when they say ith character, you have to follow the zeroth index. That's what they are trying to tell you. To form the ith character of target, you can choose kth character from the jth string of words if target of y is equal to words. That is what they're trying to tell you, is that you have to go to the jth word. In that, you have to select the kth character. Okay, if you see what they're trying to tell you. For example, let us say we are trying to form this particular b in my target. Okay, if you see the target has this particular b. Now, in order to form that b, for example, I can take this particular b out of the second word. Okay, this is the second word. In this second word, I can go and take the character which is present in index 1. Okay, simple as that. I could have also taken the index 2 and so on, like even index 3 here in this case, the second word index 3 or the second word index 2 and so on. Okay, anything would be done. So that's what they're trying to tell you. So yep, that's what they were trying to tell you in this particular thing, that if the words are equal, that is, if a particular character in any of the words is equal to the target character, then it could be taken. Okay, but there is a very important rule coming now after this. What is that? Once you use the kth character of the jth word, that is the jth string of words, you can no longer use the xth character of any strings in the word where x is less than equal to k. In other words, all characters to the left or at the index k becomes unusable for every string. See, now let us quickly understand what they're trying to tell you. For example, let us say I want the character b. Okay, now let us say this particular character I took in order to get the character b. Okay, so what is the index I'm taking for, see this, first of all, in the words array, what is the index for this? The index for this is 1. Okay, so in the words array I'm going to take the word whose index is 1. Okay, in this, what character I'm taking, the what is the index for that character? Sorry, the index for that character is also 1. So you will write words of bracket 1 comma again 1. Okay, that is square bracket 1 again square bracket 1. Okay, so you will get this. The condition they are putting here is, once you select this, the idea here is you cannot take any other character which is present in index 1 in any of the words now. Okay, that is, if you cannot take this after that, you cannot take this after that, and so on. And not just one, even characters which are index before the index 1, you cannot take them in any of the words. And that is, let us say we are taking this, that means these two characters also you can never utilize now in future. Similarly, these two characters you can never utilize now in future, and these two characters you can never utilize now in future. Why? Because you've selected characters index is 1. That means in any of the words, not only this word, this is the word, right, I'm talking about. I'm talking about the word this one, okay, which is present in index 1. But since you have selected a character index 1, that means in any other words, I cannot go and take any character that belongs to index less than or equal to 1 now. Okay, that is what they're trying to tell you. Yeah, this is the meaning of this. Next, repeat the process until you form these strings. Okay, until you form the string target. Notice that you can use multiple characters of the same string in words provided the conditions are met. Okay, now Return the number of ways to form the target from words. Since the answer may be too large, return it modulo 10 power 9 plus 7. Okay. So this is a very standard thing that they usually give. So before writing the answer, you have to ensure that this particular module is met. I will also teach you one math property which comes with this modulo. That is, see, if you are your result you are having it and we want to return it modulo, what you can do is, for example, see, the a plus b, let us say whole, you are doing the modulo. Instead of doing that, what you can do is a modulo this particular number plus b modulo this particular number and the whole result modulo this particular number. If you do this, it will be very helpful because you won't have to take the answer to such a level and then do the modulo at last. Okay, because if you're doing in C++ and Java, the data type will also matter. Remember that it should not be exceeding the data type any level. Okay, so you can do that kind of things as well. I will show you the same. So coming to this particular example one, if you see here, they are saying there are 6 ways to do it. Okay, you can go through the example like how they are getting it, but ultimate aim is same, that once you take index, okay, once you select index, in order to match a character in the target, you cannot utilize any other words, any other characters which has an index less than or equal to that particular index. Okay, as simple as that. You can go through it and consider, you see it is around 10 power 3, this is also 10 power 3 and so on, right? And all the words are going to have same length. This is something of use to us, and they will only contain lower letter English characters. So I will show you first a very dummy approach which is expected for you to do, which expected out of you in a interview. Okay, this is the first approach. First of all, you have to target the question, that you have to show that you are capable to do it, and then we'll come to optimization. Okay, so I will show a very very simple solution, the very very simple recursive solution. It currently does not have any caching or any memorization or anything like that. Even we are not using any DP stuff here. It's just a recursive solution. It is not a good solution, but we will slowly add things here. I will show you how the things work after the addition. Okay, first of all, see here, I'm capturing the length of the target, the length of the word, that is for each word. If you see here each word, if you see what is the length of that, that is called an underscore word. The length of the target is called an underscore target. Okay, I am defining a particular function. Okay, this is the function for me, and this is the function call. Okay, the function call will return me the result that I'm going to return as the final answer. Okay, so what is this function going to do? Let me zoom in and let me show you now. I've already calculated the modulo and I'm storing it as a mod. Okay, I will be doing this thing. Okay, 10% mod at last. Okay, fine. Let us see now. Now this function will take the first argument is the target index. The second argument is the word index. That is, I am currently looking for a word. Okay, that is, for example, you see this is the target. So let us say the target index 0. That means I am currently searching for a word to match my 0th index. Okay, as simple as that. To match my target index, and I have to start searching from word index onwards. Okay, word index will be any index out of these three. Okay, that is, here the length is 4, so the index will be 0 to 3. Okay, something like that. Now these are like always these things are like generic to Python. Like I'm declaring them non-local because they are being declared outside, so that's why they are being declared as a non-local inside this function. Next, these are some of the edge cases. Okay, that is, these are the base conditions used to terminate the recursion. Remember, it's a recursive function. Okay, so these are the test cases to terminate the recursion. So what are they? If the target index equal to length of target, that is, we have reached, that is, we have covered all the characters here. Okay, all the characters in the target, that means we have now done. So we are returning one. Returning one means, basically means that we have reached one solution. Okay, this is what you are seeing is from these ones. Okay, so I will be returning whenever I'm reaching a particular solution. These ones will keep adding and the final will get the answer. Okay, as simple as that. Now, if this is not the case, if let us say this is not the case, then we'll check this condition. If word index is greater than or equal to, that is the length of the words. Okay, that means we were not able to get a particular target index, and we have crossed, that is, we have searched all the indexes possible in the words, in each of the words, but we are not able to get it, and that's why the word index is exceeded. In that case, we have to return 0. That means we have to stop recursion and return 0. It is not going to contribute to the answer. Okay, as simple as that. Now, these are two of the variables that I'm declaring. I'll show you why this is being declared separately. Now see here, what I have to do, see, after all these cases, now the actual search will start. That is, in this particular index, in all the words, I have to search for this character. So I hope the thing is very clear to you. In this index, among all the words, I am going to search for this character. Let me show you how it works. I'm going through all of the words, and in each of the word, I'm going to the word index. Okay, if that is equal to target index, in that case, I am sure that, okay, I can proceed further. I have found a match. I can now proceed further. Now, what I'm going to do, I'm going to call this function. Okay, just pay attention here. I will tell you the rest of the things, but pay attention here. I am calling this function again. This is a recursive call. Okay, I'm again calling this function inside the function. So what I'm doing this time, I'm passing target index plus 1. Why? Because the current index has been found. Okay, here the current index has been found, so I'm doing a target plus 1. Okay, and then the word index also I'm doing a plus 1 because the current index was used here, so I have to go with the next index for the next character in the target. Okay, as simple as that. This function is being called. Now, what will happen is, for example, see here, if you see, this a is also in the third index, index 3. This a is also in the index 3. So if I'm searching for a word, so I will find this also in the third index, and this also I will find in the third index. For that reason, what I will do is k is 0 initially. Let us say if k is 0, that is if the first time I'm finding a word which is matching the target, in that case I will do this recursive call. I will get some value here. I will do a percentage model of this, then I will store it in k. Okay, then I will do a temp is equal to temp plus k. Next time, for example, if you see, this will the full first function call. The next time when I see a, I don't have to do this function call again. Okay, I don't. Okay, just a second. Yeah, I don't have to do this function call again because I already know what will be written. That is already there in the k, right? Because k is not equal to 0 anymore. Then I can simply do temp is equal to temp plus k. Okay. The idea here is, see, currently I am searching among all the words which word has the word index equal to the target index of the target. Okay, if I'm there, let's say there are more than one. In that case, this function call can be done only once. Okay, no need to like do this function again and again because the result will be same. So just store the result in k, and whenever this condition again true, okay, simply use the kth result because k will not be equal to 0 after that because k is changing here. So simply take the k and add it to the temp. Okay, as simple as that. Now we are done. This will keep continuing, and for all the words we will checking, and after that we are done. Now there could be a case, right, where we are, let us say, even if it is matching, even if the word index is matching, but still we will skip it. That is, we will not take, but we will skip. Okay, because remember we have to take all possible cases, right? So this is going to be the function call for that. If you see in this function call what we are doing, the target index is remaining the same. In this we are doing target index plus 1, but here we are retaining the target index. That is, this particular index itself will be searched in the next word index. Okay, so I'm just doing a word index plus 1. Same thing here, I'm doing a percentage modulo, and then I'm and adding it to the temp, and finally I'm returning temp plus mod. Okay, as simple as that. The function call is 0 comma 0. That means I am going to search for the 0th character in the target with the 0th character in any of the words. Okay, as simple as that. Okay, that is what it will be. So let me quickly run this and show you how it looks. And it looks something like this. So remember, this was the I will say the most important part. If you have done this, only the next thing you have to do is optimizations. Now as you can see, this is clearing the basic text cases, but if you segment this will not work because this is not the optimal solution. Now let us see what we can optimize. See, the first thing that you can think of is, for example, see here, currently whatever are the sub problems, we are recalculating them again and again, though we have done some optimization here, but still that is not a good optimization. For example, see here. Yep. Let us say you are in this particular B. Okay. Now, before coming to this B, you had one A. So the A could be this also, that is index 0 also, or the A could be in index 1 also. But when you come to index B, you are at index 2. Okay. As simple as that. So that's what I'm trying to say. We are going to cache these things. Okay. So whenever we are reaching a particular word index for a particular target index, we should, if we know the result, that is, if we have done this previously, we should use the same result. Okay. That is going to be the idea. So in the next solution, I'm going to do that. So if you see here, now I have formed a cache. Okay. This is only addition to the previous solution. Now I'm using a cache. So if you see here what we are going to do, this is the only new addition. After calculating temp, okay, what I'm going to do, that particular temp, okay, there is a 10% modulo, I'm going to store in my cache now. Okay, remember, this is the only addition. Previously we were simply returning 10% mod. In this case, I am storing it in a cache. What is the key for the cache? This whole thing is going to be the key. Remember, these things are called tuple in Python. This can be used as a key. So what is the key? Key is having two things. First is the target index, other is the word index. That is, whatever you are passing to this function, exactly the same thing I'm storing it as a key, and for that I'm storing the value. That is 10% modulo is going to be the final value. Okay, at last, instead of returning temp, I'm returning this particular stuff. Okay, now this is the only extra line added here, and obviously instead of returning temp, I'm returning this. You can also return temp if you want. Now, what is the extra thing that we are doing? Remember, if you're returning temp, you have to return temp percent model. Okay, now only extra thing that you can see now is this part. Okay, only this part is now extra. So what is this now? See, these are the two base conditions that we checked. That is, first we have to return 0 or 1, and then we have to return 0. This is the third if condition that I'm going to introduce. What is that? If this particular key pair, okay, this is a key, right? If this key is already there in my cache, simply return the value for this cache. After that, no need to do anything extra. This particular stuff will not be executed. If this key is already there in my cache, that is, if the result is already evaluated for this particular target index and word index, simply return the result. Okay, this is the only addition. This if condition is only addition, and this caching part is the only addition. Okay, or other than that, everything remains the same. If you see, still it remains the same. Let me show the solution for result for this also. This is also clearing the basic test cases, but again, this will also not work if you segment it. That is, I will tell you the reason why, but again, I'm just telling you, this will not work. Okay, now can you quickly tell me, see, this is again a good solution, but there are some places where still modification is needed, still optimization is needed. Can you quickly tell me which place do you think here can be optimized? I will give you a quick hint here. Just go through the solution once, that is this particular function once. Can you quickly tell me? See, everything here I guess is optimal. Okay, this part, and everything is optimal. Okay, only I guess this is the part where we are not doing the things optimally. Okay, so what is we are not doing optimally? See, what is happening is in each function call. Okay, remember the number of function calls are very very huge. Okay, in each function call we are going through every word. Okay, let us say the number of words, if you see here, the number of words can be very high here. Okay, the number of words. Okay, yep, it can be up to 1,000. So for each call, remember each function call we are going up to 1,000 words, and we are checking their ith character. Okay, that is this particular character. Okay, which is not a good idea at all. Okay, for that reason what we can do is we can optimize this part. So in the next solution I will be optimizing this part. Okay, now I will show you the next solution. Now if you see, instead of what I've created is I've created another dictionary. Okay, if you see, I will just show you how it looks. This looks something like this. What we are going to do is for each index. Okay, for each index I'm let me come to example one. Yeah, for example, let us talk about this. What this tells is that in the index 3 there will be two A's in that position and a one B in that position. Okay, let me show you how. If you go to index 3, remember the index 3 means the last index in this. Let me zoom in. See, what I've highlighted now is the index 3, this one, and this one. Now, if you count them, you will see that in the index 3, among all the words, there are two A's present. Okay, that is, two of the words are having A in the index 3, and one of the words is having B in the index 3. Okay, that is what this particular term tells me. If I just pass the the index there, it will tell me which of the characters are present and that how many times. Okay, this is what I need exactly. Okay, this will help me now to avoid the you know traversing through all the words. Okay, this is what I'm going to use now. So this particular stuff is for that. Okay, I'm calling it as a word position. Okay, word pos a dictionary. It is a dictionary inside a dictionary. If you see the exact structure of it, this is how it is. This is going to be the key, and this is going to be the value initially. Inside the value, again, there are going to be keys. Okay, this is going to be the second key inside that. Okay, so this is how it will look. Now, what I'm going to do, see, this is how I'm filling it. Okay, and this is how I'm populating the value in that. First of all, I'm going through each the way I did it. No, see here I'm doing this thing inside each of the function calls, but now I'm doing this outside the function call. Okay, so what I'm doing, I'm going through each of the words. I'm going through each of the indices. That is, for each word, I'm going through all the indices. Then, if word of I is not in word pos of I, then I'm simply that is the index of it. That is the frequency of it. I'm initializing with zero, and then simply I'm doing a plus one. Okay. Whenever I see a word, I'm going to do a plus one. So this is how it will look. I'm again showing you. See, for index 3, it is telling me two of the words have A and one of the words have B. Okay. Similar. Let us say about this. For index 2, two of the words have C and one of the words have B, and so on. Like, I hope you get it now. Okay. So this is how I'm populating it, and this is how I'm printing the result. Okay. Now let us see how it is going to help me. This is, remember, this is the only addition that I've done now. Now what I will check is, see, this is the exact same thing here. Now this is the only addition that I've done. Okay, let me show you how this works. Remember this thing I commented out. This was there in the previous solution. Now instead of this, I'm going to use this. What is that? It is just checking if the target index, that is target index of target, if it is there in word positions of the word index. Okay, if it is there, then see, it will just tell me. See, it will just check whether A is there or not. Okay, for example, A is there or not, or B is there or not. It will just check. Remember, this two we have still not used. To use this two, what we are going to do is this. I will do the function call. Okay, I will do the function call. Something will be written in this function call. Okay, this I am going to multiply with something. Okay, what is that something? This something is this. Okay, what is that? For example, as I mentioned previously, let us say A is present two times. So instead of doing the two function calls, what I'm going to do is get the result of A and then multiply the result with 2. Okay, that is what I'm going to do now. Okay, so this is the function call for this A, let us say, and then since it is present two times, let us in same index it is present two different words, so for that reason I'm going to multiply the same result with 2. Okay, and then when I get the result, I'm going to do a percent modulo. This is being stored in K, and then we are doing 10 is equal to 10 plus K. Okay, rest of the things are exactly same. This is the function call for, let us say, we want to ignore, even if it is present we still want to take it. Okay, this is already there in the solution. Okay, this part is already there, so I'm not going through in detail of it. Okay, so yeah, and after that exactly everything remains the same. Remember, only this is the addition. This is only addition. Remember, because of this, it is now this part what I'm highlighting now is O of 1. Okay, in this case it was not O of 1. Okay, this part was not O of 1. It was like O of word into word length. Okay, something like that. But here we have made it O of 1. Okay, it is very quick now, as simple as that. So if you segment this solution, that is the third solution I'm showing you, this will be accepted. Okay, it will take around I can say like around 1900 milliseconds or something like that it will take. This is a good solution. This will also accept, remember, it will kill all the test cases, but still there is scope for optimization. What is that? Can you quickly tell me one more optimization? This last optimization that I'm going to add will be here. See, currently there are three if conditions. I'm going to add one more if condition. Okay, let me show you that now. Yeah, this is the final solution. This is beating around 92% of the test cases. Remember that. Let me show you this now. Yeah, this is the final solution. Only one more operation I've added here. This is, yeah, this is the one. If you see previous three if conditions already there, this is the last if condition that I'm going to add. Okay, what is that? Now, if the length of the target minus the target index is greater than the length of the word minus the word index, then we have to return zero. What it means, I will show you now. For example, let us see here. Let us say, yeah, let okay. Yeah, let us say I'm this particular array. Let us say I'm searching for this particular array. Let us say I found this say in the last day. Okay, now what will happen? I have already B and A to be matched. Okay, it is still pending. I am currently in this A itself. If I try to match this A with this particular array, it is of no sense, right? Why? Because I have two more characters to be matched, but here there are nothing is left, right? There's after this A, there's nothing left. So the idea here is this is not a good idea to match this A with this A. Okay, so this is what I'm trying to avoid. If you do this optimization, what will happen is, just see here, I'm checking, I'm just checking how many characters are left after the current index. It is checking length of the target minus the target index. Okay, it will tell me how many characters are still left in the target to be matched, and this will tell me how many words are still left to be matched after this particular word index. Okay, so if this is still greater, if this term is greater than this particular term, that means there is not a good, even if in matching this is not a good idea to do continue, because at last we know it will not be able to match everything. Okay, everything in the target won't be able to be matched with everything in the word. Okay, for that reason I'm going to return zero. Remember this condition, if you add, like going the previous solution that I showed you, then the solution number 3, it was taking around 2000 milliseconds. If you do this addition, this will take around 700 milliseconds now. That is around 3 times this the time complexity got reduced. The runtime of the solution got reduced by 3 times now. Okay, so this is the important constraint. If you add this, it will be around 700 milliseconds. Previous was around 2000, which is 2100, let us say. So it got reduced by 3 times. Okay, that's what I'm trying to highlight. So yeah, and that was it. And now in this solution I will also show the space and time complexity part. Now see here, this cache, okay, it will store, like let me talk about the time complexity first. So okay, let me go through all the loops that I am using. So this is the first loop that I'm using. If you talk about the time complexity in this, it is going to be word length into total words. Okay, why? See, total words is going to tell me how many words are there. Word length is going to tell me how many characters are there in each word. So these are the total number of characters that I'm going through in each case. Okay, because if you see, this is a for loop, this is another for loop, and so on, right? So these are the total number of characters that I'm going through. Okay, in this for loop. So this is the time complexity for this for loop. And coming to this function now, the idea here is, see, each character in that length, okay, each character in the target will be matched with each character in the word. Okay, each character in all the words. Okay, so for that reason, the time column for this is word length into target length. Okay, as simple as that. So if you add these two, you are going to get, sorry, yeah, this one. If you add this one and this one, you are going to get the overall time complexity, that is word length into target length plus word length into total words. Okay, this is going to be the time complexity of this solution. Now coming to space complexity part, you have to be very keen here to understand what is happening. See here, now let us, these are two things that I'm using. One is the cache, and other one is the word position dictionary. Okay, these are the only two ones. Okay, now if you talk about the word position dictionary, let us say, because see, it depends on like keys, right? Keys means like if the key is repeating, it will simply increment the count. Okay, increment the frequency. It will not show another key for that. So we have to assume something here. Let us say in the worst case, all what is the worst case here? Let us say all the words at each index. That is, if there are three words, see here. See, if you remember clearly, there are only going to be 26 characters because all are going to small character. Okay. Now, in the worst case, what will happen is, let us say the zeroth index of each of the words is different. Okay. In that case, for each of them, we have to create a separate key. Okay. So what can happen is there has to be 26 keys for each index. Okay. There has to be 26 keys for each index. Now, how many indexes can be there? There can be 20. There is word length indexes. Okay. So word length into 26 is going to be the worst case complexity, space complexity for this particular data structure. Okay. Now coming to cache. In the cache, basically idea here is, since I'm caching the result, if you see here, this is the cache part, right? Here I'm caching the result. Okay, I'm just searching this in the cache, and this is the cache part, right? Yeah, this is the one. So idea here is each target index will be matched with the word index. Okay, so the way it works is, it will take around word length into target length spaces. Okay, this many key value pairs will be stored in this. Okay, so now if you see how it looks, space amount will be word length into target length. Okay, it is coming from this, and 26 into word length. Okay, it is coming from this. Remember, this we got after assuming that we are talking about the worst case. Okay, now 26 is a constant, so on the whole this will be equal to something like a word length only. Now, but which is better, was just a word length is bigger, or a word length into something else is bigger? So for that reason, since this is not a dominating factor, we will remove it, and only this part will be retained. Okay, this is going to be a space complexity, and this is going to be a time complexity for that. Okay, So yeah, I hope like I have like done justice to my solution. I've tried to explain everything whatever is possible out of the solution. I hope I am able to make this solution slightly easy for you, make this question slightly easy for you. If you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. If you have any questions, please do post in the comment sections. I almost reply to every question that is being asked. Yeah, that was all for today. Please subscribe. This really gives us a lot of motivation to continue further. And for more such solutions, please tune into my channel. Please hit that like and subscribe button. Yeah, see you tomorrow. Thanks a lot.